Hello and welcome to Code Geeks. This time, X and me, Gizmo, are talking about binary encoding. Say hello.
Hello, everyone.
We will now talk a bit about how a computer works in general. So a computer does only work with zeros and ones. There is nothing else, just 0 or 1 and nothing else. But there is such a large series of different combinations of 0 and 1, 0 and 1. You can encode anything with it, like video games, like videos, sound, text. It's all just 0 and 1. A unit of this is a bit. A bit can be either 0 or 1, and that's what's all about computers. That's all computers do, just changing bits, working with bits, and so on. So then let's just create a new project. You choose another PHP project and you name it lessons maybe. And this will be our playground. Create a new PHP file. Nice naming. We start with a scratchboard comment. Please type / and star and another star. Press enter now. Now it is in documentation mode. Let's start with a bit. A bit is either 0 or 1. Type just a 0. Now press enter. Now type NIBBLE. This is 4 bits. You type 4 zeros. This is a NIBBLE. A series of 4 bits. Okay. It can be either 0 or 1. A NIBBLE is 4 bits and a byte is 8 bits. Yeah, and you please put a space between the nibbles. You have a byte there with 2 nibbles. You can put a space between after the 4th. So a byte is just 8 bits or 2 nibbles. You have a high byte and a low byte. There's 2 nibbles. It's an old term, but you can call it the high byte and low byte. Those are nibbles. And that's okay. Let's just work with bytes. Press 1 enter, please. Type a random byte and now try to convert it to decimal. I always, when I do such things, I write a table. Go to line 7. You put the 1 about the 1 bit and the 2 above the 2 bit, a 4 above the 4 bit, an 8, and so on. We have an easy table and it's for the beginners. You just can add the values together, like 64 plus 16 plus 8 plus 4 plus 2, because those are the bits that are set. So you just add its value. We will later do a general solution. This is just an introduction. Now let's start coding, I would say. We write a function. I do not want you to know already the PHP syntax. You will learn by doing function. You can also control delete fun, and it helps you already. You can type function statement maybe. We call it binary to decimal. And the first param will be named binary. My convention is lowercase function names. Like binary to decimal, you would start with a lowercase, and then camel case, a capital T. This is called camel case, and capital D for decimal, string, space, $binary. And then I have an enter after the first bracket. This is my code style. And you have an enter at line 15 as well. Okay, so we convert a binary to decimal. So what do we return? An integer, or do we want to return a string?
Integer.
Integer. Okay, then maybe we can also say after the string binary, colon, Doppelpunkt in German, int. Now line 14, we declare variable $back, and then next line, return back. So this is the skeleton, the structure of the function. We have an integer to compute and we return it. And we return it by computing it from the binary. Go to line 17, type echo binary to decimal. It's now a string, quotes for a string. This is a sample from above, 0, 1, 0, 1, 1, 1, 1, 0. Save and run, 0. Because we return 0. Now your job is to make back return the right value. What I want you is to write a function now. We start a new line 15 between the 2 lines. There now we write the logic. You can rename back to result. And now you need a for loop. For in parentheses, enter, for $I equals 0, I smaller than 8, smaller 8, semicolon, $I plus plus. So this loop is just counting from 0 to 7. You need something different, of course, but this is a start for you now. We learn also a bit syntax on the fly, and we will do an OOP course as well. very soon, because syntax is essential. We need to cover such things first, but binary encoding is the most fundamental thing of information technology. You know, everything is just 0 or 1. Okay, now line 16, parentheses, the function parentheses, curly ones. Echo $I. Okay, now run it again. Okay, so we have an output now. It's counting from 0 to 7, and the final 0 comes from the echo in line 21. Make line 17 new. So now let's analyze the binary character by character. And we say $C for character equals $binary in array brackets, $I in between them. So now it gets the next character from the binary, but it's reading from the left side instead of the right. That's the problem here. Line 15 new, $binary equals str strref. Then maybe do echo C. Line 19 new, if round parentheses, $C equals in single quotes equals 1. If it's a 1, we need to add something, right?
Yep.
Enter function parentheses. Now, what do you need to do if it's a 0? 1. Add it to the result. So you type $result plus equals this to add result plus equals $value semicolon. Line 21 new. Line 21 $value equals. Now you have to compute the value of the bit. If it's bit 0, or if it's a 1 bit, you have to add a 1. If it's 2, you have to add a 2. If it's a 4 bit, you have to add a 4, 8, and so on. You have to add the right value now. You have to compute the value of the current bit now. And the current bit is the I. In line 16, let's change it from 0 to 1 and then smaller or equals. This is more readable. From 1 to 8 is this now. And value equals line 21, power of. So you type POW, enter. So the base, what is the base?
2.
Yes, because we have binary base 2, only 0 and 1, two different values. Our normal decimal system is base 10. And now the second parameter is the power, the argument, the exponent. Now what's the exponent?
Should be the
correct. And we have the I perfectly aligned. We start from 1 to 8. It should be perfect. Now save it and put a breakpoint at 14. Double click, yes, and debug. Now we are halted at line 14. We have the binary. We have no result yet. If you step over, we have a result of 0. Step over, yes. You know, see, result 0. Now we are reversing the binary. If you step over, it will get reversed.
Yes.
You see, reversed. Now we are entering the loop and step over. Step over. Yeah. See. So is this correct?
No, it will be false.
Yeah. Do you see the problem?
Yes.
Then stop the debugger.
But what do you mean if I see the problem? That
yeah, the character is 0 as 1. But if you look at the binary, the first character should be 0. It's because we are counting from 1 now.
No, I'm lost.
Step over. Step over. Step over. Now I is 2. Now you're here. Now value. Look at the value calculation. Step over. Step over. Now value is 4. That's a 4-bit. Is this correct?
What is the numbers that we have?
Result is 0 and value calculated in line 21. This is the second bit is a 1. Value got computed to 4.
No, if the value is 1, then it should be 2.
Yeah, that's the problem. The problem is in line 21. So I would change line 16. I would change line 60, start from 0 again. Smaller 8. The equal sign is wrong, yeah. And then the -1, you can delete the -1s. And in line 21 as well. The -1 is wrong now. Because we start from 0 now, and we need to calculate. The problem is the power of 2 of exponent 0 is 1. And power 2 exponent 1 is 2. Okay, so this is binary to decimal implemented ourselves with just some power and some addition. This algorithm is highly inefficient, but it gets you an idea what is binary, how to compute binary to decimal. Let's look at the draft. What else should we explain? We have now implemented basic binary to decimal, showed you how to debug it in the CLI. Now one thing we want to show with the setup you have, if you go with your browser to your local host, we now know how to convert between binary and decimal. And I want to show you now some basic stuff you can do with binaries or Boolean values. You can also call them Boolean values, yes or no, true or false. Binary also has logical Boolean operations like AND or XOR and NOT. Logical operations, line 9. Click it, please. We talk about logical, and this is the symbols, line 11, the ampersand and symbol is for the PHP programming language. And if you open your binary encoding project again, yes, line 31, new. Let's assume we have a bit, call it $A equals 1, semicolon, $B equals 1, semicolon. So let's assume we have 2 bits. And now you do $C equals $A ampersand $B. Semicolon, echo $C, echo $C, comment line 29, comment it either with a hash or this way, yes, save it. What do you think is the output?
C equal A and B.
And B, exactly. And this means if both A and B are true, then the result is also true. It's an AND. If both are true, and if both and A and B are true, C is true too. So the output should be
true.
Yeah, run it. Do a new line in line 31 between A and B. Make them both on one separate lines, A and B. And now make A equals 7 and B equals 5. What do you think is the output? As a the fun fact, it's not true and false, it's just bits. After line 32, make a comment and write it down in binary. And now for B the same. So what do you think the output is?
I don't know.
Run it. I say it's 5. Make line 34 new. Just a comment under your bits and then align it to the other zeros and 1. 0, 0, 1, 0, 1. Because from right to left, 1 and 1 are 1, 1 and 0 is 0, 1 and 1 is 1, 0 and 0 is 0. And this is 5. Do we want to do other operators as well? If you look at the draft, there is OR, there is XOR, and there is NOT. It's the same stuff, but different operator. It works on bits, logical operations on bits. Okay, so let's assume instead of AND, we are now doing OR. And OR is this is a Boolean OR. This is wrong. Only one pipe only. Yes, this is this. And what is the outcome? What do you think? This is OR, and then it's XOR. OR is at least 1, needs to be true, and XOR is exactly 1, needs to be true.
So this will be true, this will be true, this will be false. I would say 7.
Yeah, I agree. Then we have XOR.
2.
2. Okay, and then the last logical operator is a NOT. You can make line 32 new, just a comment. The tilde, this needs only one parameter. This is just negating. 0 becomes 1 and 1 becomes 0. So you have no operator for this. It's just negating. So we have no B. So the NOT of A is 1, 0, 0, 0, and the NOT of B is 1, 0, 1, 0. So this is about logical operations, what you can do with bits. The CPU does this stuff a lot. Now go to the draft again. And now we go to line 16, arithmetic operations. Addition, subtraction, multiplication, division, modulation, power, square root, logarithm. Well, let's talk a bit about arithmetic operations. You can add 2 values, open your binary encodings again. Line 35, make a plus. What is the outcome?
12.
12. Imagine your CPU only does 4 bits, only a nibble in your CPU. You have nothing more, only this nibble. Now change B to 12. Adjust the bits. Now, what is the outcome?
19.
Run it. And now do the solution line 34, the bits, the result bits. Do it bit by bit. It works just like school edition. Do it bit by bit. You start from the right.
1 and 0.
Is 1.
1 and 0. 1.
Yeah.
1 and 1. 2.
No. We have binary. It's 0 with 1 carry.
Yes, so 1 and 1, 2, so put 0 and 1 carry. 0 and 1, 1, so 0 and 1 carry. And then here 1.
So what happened now? We need 5 bits, but we had only 4. And our CPU can't handle it because it only knows 4 bit. It's only a NIBBLE CPU. It overflows. We have a problem now. It overflows. The result will be 3. And this is called an overflow or a carry. Then the carry bit is set. If the CPU overflows, it sets a special bit, the carry bit in your CPU, says, oh, this operation is wrong. And well, this can cause also security trouble. This can lead to system exploitation because C is an unsafe language and arithmetic is hard. Even addition is hard in computers. If you go to the bare metal, to the root cause, to the transistors, even addition is quite hard. Also in mathematics, if you study mathematics and you have to prove addition, it's pretty hard to prove addition is wrong, is correct. Okay, I think this should be enough recordings now for the binary tutorial lesson. And thanks for watching. I hope we will see you again later.